0x0400 is equal to 1024, which is the number of subscribers that this channel has surpassed. So in this video, I'm going to explain how to convert hexadecimal number, the number that you see on the left, to human readable number, the number that you see on the right. And in the process, I'll explain how bytes 32 and uint256, the two basic data types in smart contract language like Solidity and Viper, are equal. In other words, how to convert between bytes 32 and uint256. So first, let's understand bits, bytes, and hex. One bit is equal to 0 or a 1. So I'm going to ask you a simple question. How many numbers can one bit represent? Well, since a bit is either equal to a 0 or a 1, this means that a single bit can represent two numbers. One byte is equal to 8 bits. So you can think about it as a sequence of zeros and ones where the length of the sequence is equal to 8. For example, a sequence of 8 zeros is 1 byte. Another example is a sequence of ones and zeros. And another example is all ones. These all represent a number that is 1 byte. So now I'm going to ask you the question, how many numbers can 1 byte represent? This isn't a trivial question, so let's take a step back and try to answer simpler questions. And then we'll come back to answer this question. So let's try to answer the question, how many numbers can 2 bits represent? Well, this is easy. We can just count them. 0, 0, 0, 1, 1, 0, and 1, 1. That's 4 numbers. How about 3 bits? How many numbers can it represent? This time, instead of listing out all the possible 3 bits and then counting them, let's be a little bit clever here. We know that all 3 bits is either going to start with a 0 followed by 2 bits of zeros and ones, or it's going to start with a 1 followed by 2 bits of zeros and ones. And how many ways can we have a 0 followed by 2 bits of zeros and ones? Well, this is equal to the number of 2-bit representations. And for the same reasoning, the number of possible ways that we can have a 1 followed by 2 bits of zeros and ones is equal to the number of 2-bit representations. So in total, we have 2 times the number of 2-bit representations. The number of 2-bit representations, we know that it is equal to 4. So this is equal to 2 times 4, which is equal to 8. We can apply the same reasoning to calculate the number of 4-bit representations. A 4-bit sequence starts with a 0 followed by 3 ones and zeros, or it's going to start with a 1 followed by 3 ones and zeros. In both cases, the number of possible ways that we can arrange zeros and ones is equal to the number of 3-bit representation. We add the two cases up, and we found out earlier that the number of 3-bit representation is equal to 8. So the total is equal to 2 times 8, which is equal to 16. So let's summarize what we found so far. We found out that a single bit can represent 2 to the power of 1, which is equal to 2 numbers. 2 bits can represent 2 to the power of 2, which is equal to 4 numbers. 3 bits can represent 2 to the power of 3, which is equal to 8 numbers. And 4 bits can represent 2 to the power of 4, which is equal to 16 numbers. Notice that every time we increase the bit by 1, we double the number that it can represent. Also notice that the number representation is equal to 2 raised to the power of that bit. I hope you see the pattern here that n bits can represent 2 raised to the power of n numbers. We can now answer our original question of how many numbers can 1 byte represent. We know that 1 byte is equal to 8 bits. So this means that 1 byte can represent 2 raised to the power of 8 numbers, which is equal to 256. So for example, a sequence of 1 byte can represent any number between 0 and 255. Now I want to show you how to convert a sequence of 1 byte into a decimal value, a number that we can easily understand. So here we have a sequence of ones and zeros. We start from the leftmost value, which is equal to 1. Counting from the right and starting from the 0, this will be the 7th number. We take the power of that position. So in this case, it will be 2 to the 7. The 6th position is equal to 0, so we don't add anything. Same with the fifth position. The fourth position is equal to 1, so we add 2 to the power of 4. Likewise, for the third position, we add 2 to the power of 3. The second position is equal to 1, so we add 2 to the power of 2. The first position is equal to 0, so we don't add anything. The 0th position is equal to 1, so we add 2 raised to the power of 0. We take the sum of this, and this is equal to 157. This was an example of how to convert binary representation into decimal values. Keep this in mind as we talk about hexadecimal values. The way we convert hexadecimal representation will be similar to how we converted binary into decimal values. Hexadecimal are numbers that are written in combinations of 0 to 9 and A to F. 0 to 9 in hexadecimal is equal to 0 to 9 in decimal values. However, 10 will be equal to A, 11 will be equal to B, 12 will be C, 13 will be D, 14 will be E, and 15 will be F. So for example, if we have a hexadecimal value 3EA, here we prefix it with a 0x, just to be clear that this value is a hexadecimal value. This will be equal to 3 times 16 raised to the power of 2. The 2 comes from the fact that the 3 is in the second position, starting from the right and counting from 0. Next, you add 14 times 16 raised to the power of 1. 14 comes from the fact that E is equal to 14. And we raise 16 to the power of 1 since E is in the first position. Finally, we add 10 times 16 raised to the power of 0. Again, this is because A maps to 10. And we raise 16 to the power of 0 since A is in the 0th position. This will be equal to 1002. So now I want to show you that a single character of hex can be represented in 4 bits. We know that a single character of hex, so from 0 to 9 and A to F, is equal to a number between 0 and 15. That's 16 numbers, or 2 raised to the power of 4 numbers. Earlier we saw that 2 raised to the power of 4 numbers can be represented in 4 bits. So for example, if you have a hex value of C, A is equal to 10, B is equal to 11, so C is equal to 12. We can rewrite this as A plus 4, which is equal to 2 to the 3 plus 2 to the 2. And in binary, this will be equal to 1100. So now I'm going to show you how bits, bytes, and hex all relate together. 1 byte is equal to 8 bits, and 8 bits is equal to 2 hex. Let's see how. We know that 1 byte is equal to 8 bits. Rewriting 8 bits, it is equal to 2 times 4 bits. Earlier, we established that a single hex can be represented in 4 bits. So here, 2 times 4 bits can be represented in 2 hex. Let's see how to convert this into hexadecimal value. The 7th position is a 1, so we add 2 raised to the power of 7. Likewise for the 6th position, and the 5th, and the 3rd, and the 0th position. Anything greater than the 4th position, we can factor out 2 raised to the power of 4. And we write this equation in base 16. So 2 raised to the power of 4 is equal to 16 raised to the power of 1. And 1 is equal to 16 raised to the power of 0. We evaluate the expressions inside the parentheses, and it gives us 14 and 9. In hexadecimal notation, 14 is equal to E, and 9 is equal to 9. Since we're in base 16 now, we can just simply write E and F. So this gives us 0xEF. And that was an example that a sequence of 1 byte can be represented into hexadecimal characters. So finally, we can convert the hexadecimal value 0x0400 and see that it is equal to 1024. The first value in position 3, counting from the right, is equal to 0. So this does not add anything. The value in second position is equal to 4, so we multiply 4 by 16 raised to the power of 2. The first position is a 0, and the 0th position is also a 0. So we have 0x00 is equal to 4 times 16 raised to the power of 2, and this is equal to 1024. Lastly, I'm going to show how the two data types, bytes 32 and uint256, relate to each other. So we know that bytes 32 represents a data type of size 32 bytes. We saw earlier that a single byte can be written using two hexadecimal values. So 32 bytes can be represented using 32 times two hexadecimal values. This is equal to 64 hexadecimal values. Each hex can be represented using 4 bits, so a sequence of 64 hex can be represented in 64 times 4 bits, or in other words, 256 bits. And lastly, a sequence of 256 bits can be converted to uint 256. And that is how bytes 32 can be mapped onto uint 256, and also the reverse of mapping uint 256 to bytes 32. Thanks for watching, and I'll see you in the next video.